In this video, I'm going to remind you how to use synthetic division. So remember, when you have a polynomial function and we're trying to use synthetic division, what we care about most are the coefficients of our terms and the value of whatever makes our factor, our potential factor, 0. So if we're looking at this polynomial function, we know that our quadratic x to the fourth has a leading coefficient of 1. So we have 1, -3, -5, 2, and 9. And we know that an x value of 3 is going to make this 0. So what we do is we take a look at all of our leading, all of our coefficients and then our constant term, and we copy those down. So 1, -3, -5, 2, and 9. Let's give myself a little bit more space here. 2 and 9. And then we take the value that makes this potential factor 0, and that's what we're going to use for synthetic division. Now, if you recall, when we're doing synthetic division, what we do is we take the coefficients. So the first one, we bring it down, and then we take its product. So 1 times this number, so that's 3. And then instead of doing subtraction like we normally do in long division, we add these values. So it's plus 3. -3 plus 3 is 0. 0 times 3, that's 0. -5 plus 0 is -5. -5 times 3, that's -15. 2 plus a -15 is -13. And then -13 times 3, that's -39. 9 minus 39 is -30. And then what does all of this mean? Well, if you recall, right, from up here, we know that this was the coefficient of a 4th degree term. This was the coefficient of a cubic term. This was the coefficient of a quadratic term, of a linear term, and then of a constant. This 3 here came from a potential factor of x minus 3. It's a linear factor, right? This just means that x is equal to 3. So when you divide a 4th degree by a linear term, your resulting polynomial or your resulting expression is going to be 1 degree lower than this. So we have now the coefficients of a 3rd degree term. But what is this -30 here? This -30 represents the remainder. This is the remainder. Now, if the remainder is 0, then that means that x minus 3 was evenly divided into this entire polynomial function. So we now have a cubic. So this is x to the 3rd. This is the coefficient of an x squared term, of a linear term, and then of a constant term. So we can actually write this function using this our new coefficients. So we have 1x cubed plus 0x squared minus 5x minus 13 plus, and then with the remainder, just like you would with any other long division, let's say we were doing 10 divided by 3. 3 goes into 10 3 times. 3 times 3 is 9. And we see that 3 can't go into 1. So if we were going to write this as a mixed number, this would be 3, and we put the divisor down here and then our remainder here. So 3 and 1/3. So the same way that we did in this, we're going to take this here. Our factor, the x minus 3, goes down here, and our remainder goes in the numerator there. So this would be some new function. It's not a polynomial, but it would be our new function after we've done our quotient. So let's call it g of x. So this would be our new function.